Hello everyone, so welcome back to my YouTube channel. In today's video, we are going to solve today's problem, that is problem number 33, search in rotated sorted array. So first of all, let us read about the question. We are given an array of integer nums which is sorted in ascending order with distinct values, but it is possibly left rotated. It is somehow rotated and we have to find the target element. So the question is very simple. We are given, first of all, we have an array which was rotated k times, or at at most k times. But let us suppose that we are given with an array 0, 1, 2, 4, 5, 6, and 7, and this is left rotated by third indices. Left rotated, it means that if it is first time rotated in the left direction, okay, so if it is rotating in the left direction, so the number will be what is the number? Okay, 0, 1, 2, 4. Okay, so if we are given an element 0, 1, 2, 4, 5, 6, and 7, if it is left rotated, it means that our number will be 1, 2, 4, 5, 6, 7, and then 0. If it is k equal to 2, we will have 2, 4, 5, 6, 7, 0, 1. If k equal to 3, we will have 4, 5, 6, 7, 0, 1, and 2. So we are given this array. So it is rotated three times. As you can see in the problem, we are given an array and then it is left rotated by three indices and then become this one, 4, 5, 6, 7, 0, 1, 2. Now we have to find the target element. Our target element, we have to find the target element in the given array. So the basic approach and the very simple approach is we can iterate in the array and then we can find the element. If the element exists in the if the target element exists in the array, we can return the index of the element. But this approach will take us the time complexity of big of n. However, it is given, however, it is the condition that we have to solve this problem in big of log n time runtime complexity. So we cannot think of writing a brute force solution. However, it will get accepted in on the lead code, but it is not a correct way to solve this problem. So we are not going to solve this problem in a big of an approach. So what we can write is we can think about okay, whenever we see that if a problem can be solved in big of log n time complexity, we have to think about the binary search algorithm. So what this binary search algorithm? I hope that you all know about binary search algorithm. With this binary search algorithm, if we are given a sorted array, suppose we are given a sorted array and we have to find the target element is 4. Now if 0 and this is 1, 2, 3, 4, 5, and 6. Okay, so our middle, okay, suppose if we are given 5. Okay, yeah, we will have to check whether 4 is greater than or less than 5. If 4 is less than 5, then obviously we have to if 4 is less than 5, then we have to move our search space in the right direction. And if suppose if we have to, instead of 5, if we have to find the number 2 target, if the element was target 2, then we have to compare this 4 with 2. If 4 is smaller than 2, if 2 is smaller than 4, or we can say 4 is larger than 2, then obviously we have to search in the left direction. So on the basis of some condition, we will check whether in which space we have to go, either on the right space or either on the left space we have to go. So this is the basic approach of the binary search. On the basis of some particular conditions, we are going to reduce our search space, which will eventually reduce our time complexity. This is called as a concept of binary search. However, you can see that we are not given a completely sorted array. If it was a completely sorted array, then it would be an easy problem, and by using a binary search, we can easily solve it. But as you can see, this problem is not an easy problem, because because these indices, because the elements of this array has been rotated for some k times. Okay, so we cannot directly apply the mm, binary search. However, we can use some modification in the binary search to find the solution. Let me tell, there are two approaches to solve this problem. First one, sorry, okay. So there are two approaches to solve this problem in the term time complexity of big of log n. The first approach is, what we can do is, first of all, we are given a some, let us take some example, 4, 5, 6, 7, 0, 1, and 2. If we are given this array, then first of all we will find the pivot element. What is pivot element is? The pivot element is the particular element from where the other part of the array is sorted. Suppose in here the pivot element is 0, because from 0 we can see that the right direction of the 0 is sorted and the left direction is also sorted, like 4 5 6 7 and 0 1 2 is already sorted. So the first approach is that we will find, first of all we will find the pivot element, and we will find the pivot element by using the time complexity of big of log n. We cannot iterate each and every element and then check whether whether the element we have, we cannot check whether this 7 is greater than 6 and is greater than 0, then it is called as a pivot element. But we cannot take a bit, we cannot search it big of n, because eventually it will take then big of n time complexity. Then it doesn't matter whether we are going to search the 7 or the target element, it will lead to the same time complexity. So what will we do? We will find the pivot of this array by using big of log n time complexity. How will we do? We can suppose if 0 1 2 3 4 to pivot minus 1, I'm going to search my target element. If it will be founded, then I will return that indices. And number third will be, I will be checking from pivot of the element to the n minus 1 complete size of it, and then I will find the target element. So this okay, but this approach will you takes you 3 into log n. It means that you are going to use a binary search optimization three times in a row. So this obviously will get accepted, and it is satisfy the condition of big of log n, because three times log n will be big of log n only. But however, in interview you will be asked to solve this in a single pass. So the next approach to solve this problem in a single pass is, yeah. So the next approach to solve this question in sorry, okay, huh. So this the next approach to solve this in a single approach is that what we are going to do, we are given 4 5 6 7 0 1 and 2, and our target element is our target element is 0. First of all we will find whether this mid, this will be mid, okay. 5 6 0 plus 6 by 2, that is 3. So this element, this is equal to our 0 or not. If it is not, then then already we okay. So if we are going to find a mid element, then obviously one of these part, whether it is a left part or the right part, is already sorted. We don't know which part will be sorted, but one of them will be absolutely sorted. So we can check whether this part is sorted or this part is sorted. As you can see that 4 5 6, this part is already sorted. So we will check we will check this t equal to 0 in the left part, okay. So we will check whether this t equal to 0 lies between 4 and 7 or not. We will check whether this is correct or not. If this is not correct, then we will eliminate this search space, because we are not going to find the element in this row. Then we will check in the right space. So this is a basic approach. Basic approach is find, first of all we will find the mid of the element, and the second we will check whether the left is sorted or the right is sorted. If if left is sorted, then I have two options. First of all, if left is sorted and the elements lies within them, then I will move our jth index or the right of the element um, to the mid minus 1, because I'm going to reduce my search space by I will be 0, okay. So in this case, I equal to mid minus 1 and I equal to 0. And if it is not present, then obviously I will be increases to mid plus 1. And if it is a right sorted, if this is a right sorted element, then what will happen? We will check whether our target elements lies within them or not. If it lies within them, within the particular sorted array, then what will we do? We will just instead of we will reduce our space by I mid plus 1, and j will remain at the same position where it is. And if instead of right sorted, and okay, and if it is not present in the element, then I have to reduce the j will be reduced to mid minus 1, and this will be the problem. This will lead to the solution of this problem. So let me show you the code how I'm going to write this code. Okay, so this is the code of the solution. Like int l equal to 0 r equal to nums dot size of 1. We will check we will first of all, this is the code to find the mid of the element. Then we will check if the nums of mid is equal to target, then we are going to return the mid because it's our answer in that case. And if not, nums of lel, it means that we will check this 4 is greater than or 7. If 4 is less than 7, sorry, if 4 is less than 7, it means that already this part is already sorted, it is left sorted. So we entered into the left sorted part. Then we will check whether the number, this our numbers of num of L lies within the target to the number of mid. If this condition satisfy, if this condition satisfy, then I have to our R is here, I have to reduce our R to here, so I have to reduce the search space. As you can see that our target element was 0, and obviously this is not, this doesn't lies between the 4 to 7, 0 doesn't lies in between them. So what will we do? We cannot move our right index, right pointer to the mid minus 1. We are going to move our I equal to mid plus 1. So in the next space, we are going to solve this. Next, we will check. Okay. Next, we will check our I will be mid plus 1, that is 4, and our R will be 4, 5, and 6. So you can check our I equal to 4 and R equal to 6. So our mid will be 5. So whenever mid is 5, we can see that our element is 1. When is nums of mid is equal to target? No, we are not going to return 1 because it is not our target element. Then we will check whether which is sorted, which in which direction it is sorted. So as you can see that 0 to 1, it is already sorted. Either both of them are sorted, but first of all we will check the 0 to 1. Yes, 0 to 1 is sorted element. Then we will move our R equal to mid minus 1. So our mid was 1, and then you can see that on 0 our L and R is pointing to 0. So when we are going to find our mid will be will be 0 only. So mid is 0, and mid is the that indices only. So our nums of mid will be 0. When nums of mid is 0 and our target element is 0, then we are going to return our mid. That is our answer that we will returning. Yes, we will return the indices, not our answer. We are not going to return the element. We are going to return the indices. So our index will be 0, 1, 2, 3, and 4. So I will return the 4. So as you can see this, for this target equal to 0, we have to return 4, and you can see if this target is 3, obviously it doesn't lie, so we will return -1. For all the other cases, it will satisfy the this code will satisfy the solution. So thank you.